Today on this video, we'll be doing this previous question paper that you see here. So this is a national certificate for mathematics, and for this question paper, it was written on the 29th of July 2024. It was an X paper. It was actually written at 9 o'clock till 12 o'clock. Now on this video, we're gonna focus only on question 4. So you can only watch this video only when you are interested on question 4. But if you want to watch other questions like question 1, question 2, question 3, I will leave the link on the description where you will be able to find those videos. Also, there will be an icon that will pop up on your top right of this video. So click on that icon and watch those videos. Alright guys, so before I start though, I just like to say thank you very much guys for watching, subscribing to the channel, commenting, and not forgetting those who like and share the videos. If you haven't subscribed to the channel, subscribe to the channel. So on this video though, I'm gonna leave the timestamps whereby you are able to watch a specific question, just in case you are interested only on a specific question. But then if you want to watch the whole video, you can just watch the whole video. So let's go and look for question 4 and let's see how we're gonna solve for this question. Alright, so here's our question 4 here guys. So question 4 consists of 5 questions. So we're gonna start by doing question 4.1 and then we continue with others. So I'm going to copy this question 4.1, paste it somewhere where there is space, and then we solve it. Alright guys, let's look at 4.1. Now this question here, they want us to differentiate from the first principle if y is equaling to negative x to the power of 3. Now when we differentiate from the first principle, you need to understand there's a formula that we need to use, which is f of x prime is equaling to f of x plus h minus f of x. All this is divided by h limit h approaches 0. So this is the formula that we use when we differentiate from the first principle. Now before I continue with this question, I just like to let you know guys that I've already done videos explaining this formula, how to use it, and also I've done questions that I apply this formula. So I'm gonna leave the playlist where I've done those videos on the description, and also that playlist is gonna pop up on your top right of this question that we are doing right now. Let's continue guys and solve this problem. Now before you use this formula, you need to know what is your f of x and also what is your f of x plus h. So let's start with f of x. F of x guys is very simple to get it, because f of x is the question that is given to us. So it's actually what y is. So in this case now we know that y is equaling to negative x cubed. So f of x is also equaling to negative x cubed. Now that we've managed to find f of x, how about we find f of x plus h? Now f of x plus h also is not difficult to get it. Usually what you do, the very same expression that is given to us here, we now substitute x with x plus h. So wherever there is x, we substitute with x plus h. So first of all, you need to pay attention to this negative. So you need to include this negative here. So wherever there is x, you must put x plus h. So that's how you substitute. Then let us not forget that this x here has the power of 3. So we need to put cubed there as well. So from here, we need to factorize this f of x plus h. So in order for us to factorize this f of x plus h, we need to use the binomial theorem. Just in case you don't know much about binomial theorem, I've already made videos on binomial theorem, so I will leave the link on the description, and also I will leave the videos where I've done questions on the binomial theorem. So those videos and the link can also appear on the top right of this video, so you can click on that icon there to watch those videos. So basically the binomial theorem, it goes like this. You're gonna have x plus h to the power of n. So what you need to do here is to expand. So let's expand this. So it's gonna be x to the power of n. This is gonna be your first term. Your second term is gonna be n, and then it's gonna be x to the power of n minus 1 multiplied by h. And then your third term is gonna be n multiplied by n minus 1. This is divided by 2 factorial multiplied by x to the power of n minus 2 multiplied by h squared. So since we are differentiating from the first principle, you really don't have to do a lot of expansion here. So the third term is enough for us to able to get the right answer. So the first term, the second term, and the third term, it's enough for us to able to use this method. So do not forget that n is basically the exponent. So this 3 here, it's actually n. So put n as 3. So we're gonna use this binomial theorem to actually factorize our f of x plus h. So let's continue. F of x plus h. Let us not forget that this f of x plus h, it has negative there, so we must put negative there. Then inside the bracket, that's where we're going to apply this binomial theorem. Alright, so let's do it. So let us not forget that n is 3. So it's going to be x to the power of 3 plus 3x power of 3 minus 1 multiplied by h. Plus, now we go to the third term, it's going to be 3. And then we have 3 minus 1 divided by 2 factorial. And then we have x to the power of 3 minus 2 multiplied by h squared. Then this is within the bracket. So from here, what do you do here? We simplify, guys. So let's simplify. Don't forget this negative. Now the first term is going to be x to the power of 3. And then the second term, we're going to have 3x to the power of 2 because we have to subtract this 3 with 1 multiplied by h plus. Now, the third term, remember we have this here. So we put this on your calculator and then the answer is going to give you 3. And then we have x to the power of 1. So even if you don't write it, we are fine. Multiplied by h squared. Right, then from there we remove the bracket by multiplying with this negative 1 here. So I hope you can be able to see that. So when you multiply by this negative 1, you're going to have negative x cubed minus 3x squared h minus 3x h squared. So guys, this one here is our f of x plus h. Now that we managed to find our f of x plus h, we also have our f of x here. We can able to use this formula. We just substitute these values there on this formula. So let's continue, guys, and let's do that. So when you continue, do not forget to rewrite the f of x prime limit h approaches 0. This is going to be equaling to, so wherever there is f of x, you're going to put all of this. So we're going to have negative x cubed minus 3x squared h minus 3x h squared. Minus, let us not forget we have minus here. And then f of x. But what is our f of x? Our f of x is negative x cubed. So negative x cubed. There we go. So this is going to be divided by h. There we go. So from here we factorize or we simplify the numerator. So let's continue. F of x prime limit h approaches 0. So we continue like this. When I have negative x cubed minus 3x squared h minus 3x h squared. Now we have negative and negative. When they multiply, they're going to give you positive x cubed. All this is divided by h. Now when you look at the numerator there, we have two like terms. We have negative x cubed and plus x cubed. So this negative x cubed and x cubed, they want to cancel each other. You're going to be left with 0. So we gonna need space. So when we continue, we're going to write f of x prime limit h approaches 0. So we're gonna be left with negative 3x squared h minus 3x h squared over h. So this is what we left with. To check whether you did the right thing, guys, make sure that on the numerator, this here, you must only left with the terms that has h. If you are left with the term that doesn't have h, there is a mistake somewhere. Go and double check your first few steps. Right, so let's continue. So from here, we're going to take out the common factor. So don't forget f of x prime limit h approaches 0. So when you take out the common factor, this time let's just take h out. So if you take h out, you're gonna be left with negative 3x squared on the first term. The second term, you're gonna be left with negative 3x h. There we go. All this is divided by h. So this h and that h, they're gonna divide each other. They're gonna give you 1. So f of x prime here is gonna be limit h approaches 0. You're gonna be left with negative 3x squared minus 3xh. Now when it's like this, guys, we know that our h is approaching 0, so we're gonna substitute our h with 0. So let me create more space. Let's continue. It's time for us to substitute. So f of x prime, when you substitute now, the limit and the h approaching 0, they fall out. So let's substitute. You want to have negative 3x squared minus 3x, but wherever there is h, we substitute with 0 because we know that the h was approaching 0. So our final answer, which is going to be f of x prime, is going to be negative 3x squared. So this here, guys, is our final answer. I hope you managed to understand this question here, guys. It was not that difficult. It was just a bit long, and it needed you guys to know the formula to use when you differentiate from the first principle. Also, you need to know how to use the binomial theorem, which are the things that we've already done on this channel. So guys, if it so happened that you didn't understand, do not forget to go to the point where you got lost, rewatch the video, or you can leave a comment and ask a question. I'll try to answer you to my level best. But if this video helped you to understand this question, do not forget to like the video, share the video, and if you haven't subscribed to the channel, subscribe to the channel. But anyway, guys, we are done with 4.1. Let's go and do 4.2. Alright, guys, let's look at 4.2. As you can see, here is our 4.2 here. So I'm just going to copy this question here, guys, and paste it where there is space so that you can able to analyze and solve it. Alright, guys, so let's look at 4.2. So 4.2, we are given this expression here, y is equal to x to the power of 3 minus 12x to the power of 2 plus 36x. They want to get an aid of differentiation, the coordinates of the turning point. So here they just want the coordinates of the turning point. So guys, they never mention anything about the maximum turning point or the minimum turning point. So before you do anything else, whenever you calculate the coordinates of the turning point on the cubic graph, because this is actually a cubic graph, you need to derive the original equation that you see here. So let's derive it. So before I derive it, it is something that I need to let you know, guys. The derivative of this equation is equal to 0. So after deriving, you must know that this is equal to 0. So as you can see, this is the standard derivative or the power rule derivative. So really, you don't have to worry about it. Just in case you don't know how to derive this, I've already made videos on the standard derivatives. You can go to the description. There is a link of that video, and also that video will pop up on the icon on the top right of this video that you are watching here. Alright, so let's derive this expression here. So we know that the first term is going to be 3x squared. The second term is going to be 24x, and then the third term is going to be just 36. But let's not forget that the derivative is going to be equal to 0. Alright, so from here we do have a common factor, which is 3. So if you can divide by 3 all the times, even on our right hand side. So we're going to be left with x squared minus 8x plus 12. This is equal to 0. So now it's time for us to solve for x. So let's solve for x. So let's just factorize first. So we know that x and x, when you multiply, they're going to give you x squared. Now we need to find the terms that when you multiply, they give you 12, but when you add, they're going to give you 8. So those terms are 6 and 2. Since we have negative and positive, this is going to be negative and negative inside the bracket. So meaning our x is going to be positive 6 and it's going to be positive 2. Now that we managed to find the x values of the turning point, it's time for us to find the y values of the turning point. So in order for you to find the y values of the turning point, you go back to the original formula or equation where we have y is equal to x cubed minus 12x squared plus 36x. So what we do here, we're going to substitute the x values. So we're going to start when x is equal to 6. So wherever there is x, we substitute it to the original. So let's substitute our 6 here. So we're going to substitute here. We're going to have 6 to the power of 3 minus 12 multiplied by 6 to the power of 2 plus 36 multiplied by 6. So when you put this on a calculator, your y is going to be 0. So this turning point, let's call it turning point number 1. The coordinate is going to be 6 for x and 0 for y. Now it's time for us to do the second turning point here. So we do the same thing. Wherever there is x, we substitute with 2 from the original formula. So we're going to say y is equal to, wherever there is x, we're going to put 2, and then that we're going to be cubed minus 12, and then 2 squared plus 36, then we put 2 there. So when you put this on a calculator, y is going to be equal to 32. So this turning point, let's call it turning point number 2. So we say if x is 2, then our y is going to be 32. Right, guys, so this is basically our answers. So they don't want much here, guys. So this question, it was not that difficult at all. You just needed to know whenever you're calculating for the turning point of the cubic graph, you need to differentiate at least the original formula. Alright guys, I hope you managed to get this one. If it so happened that you didn't understand, do not forget to watch at the point where you didn't understand, or you can leave a comment and ask wherever you got lost. But then if you manage to understand this question, do not forget to like the video, share the video to your friends, and if you haven't subscribed to the channel, subscribe to the channel. So guys, we are done with question 4.2. How about you go and do question 4.3? Alright guys, let's look at this question here, which is 4.3. So here's our 4.3, guys. I hope you can see it. So I'm going to copy this 4.3 and paste it somewhere where there is space, and then we can be able to solve it. Right guys, so let's look at 4.3. So 4.3, we are given this question here. We have y is equal to 5 square root of natural log x. So they want us to differentiate with an aid of a function of a function, which is the chain rule. Basically, they want us to differentiate this expression here using the chain rule. So guys, I've already made videos on chain rules. So if you want to understand it better, you can go to the description. I will leave a video where I explain the chain rule, and also you can click on the icon that will pop up on the top right so that you can be able to watch these videos. Right, so let's look at this problem here. So you are given the problem here, y is equal to 5 the square root of natural log x. First of all, you need to simplify this so that you can be able to apply the chain rule. So you need to change the side into exponent. So you can say 5, and then we can say natural log x to the power of half. We all know that when we have the square root, this is the same as the power of half. So from here now we start equating. We can say u is equal to natural log x, and then we can say y is equal to 5, and then u to the power of half. Guys, let's look at this. So whatever there is natural log, we just substitute with u, but don't forget this natural log here has the power of half. That's why you see us having this u to the power of half. I hope you can see what's happening here. So from here you differentiate each function here. So let's start with u. So when you say du over dx, we're actually differentiating this one here. So it's gonna give you 1 over x. Guys, also I've done videos on how to differentiate natural log, so go to the description and also the icon that will pop up on the top right to learn more about this. So this is basically how to differentiate natural log x. So let's look at this one here. So let's differentiate y. So when we differentiate y, it's gonna be dy over du. So when you differentiate this is the power rule. This is the standard derivatives. Half multiplied by 5. Don't forget that you multiply by the exponent, then you say u, then you say half minus 1, because that's how you do the standard derivative. So if you continue like this, it's gonna be 5 over 2 u to the power of negative half. But let us not forget that we can change this and say 5 over 2, and then we need to change the power of negative half to positive half, so it's going to be u to the power of half on the denominator. Then from here, guys, let me just continue from here. Dy over du is the same as 5 over 2, but let us not forget that u is what? It's natural log x, so you can say natural log x then to the power of half. So basically this is the derivative of y. The chain rule, in order for us to actually differentiate the whole question or the actual problem, dy over dx is as follows. You multiply the derivative of u with the derivative of y. So let's do it. It's going to be du over dx multiplied by dy over du. So let's just substitute there. So what is our du over dx? This is very simple. Is this one here? It's 1 over x. And then what is our dy over du? Is gonna be this one here, guys. So you can say 5 over 2 natural log x to the power of half. So if you continue like this is gonna be 5 over 2x natural log under the square root natural log x under the square root. So basically this is how you do this one. Let's not forget that the power of half is the same as the square root. So this is the final answer, guys. This was not an easy question, but really it was not that difficult as well. You just need to know how to differentiate the type of functions, and also you need to know how to apply the chain rule. Alright guys, if it so happened that you didn't understand, you can go back to the point where you didn't understand, and also you can ask on the comment section how to do whatever you couldn't understand there. But if this video helped you to understand this question much better, don't forget to like, and also don't forget to share the video to your friends. If you haven't subscribed, subscribe to the channel. Guys, this is how you do 4.3. I hope you managed to get this one. So guys, now that we are done with 4.3, let's go into 4.4. Alright guys, let's look at the next question, which is 4.4. So here's our 4.4. I'm gonna copy this question here, paste it where there is a space, and we solve it. Okay guys, so let's solve this problem here. So here they just want us to differentiate this problem here. They never specify which method are you going to use. So the best way here, guys, to differentiate this is to simplify. So let's first change the sides and let's simplify. So first step here, what you can do is you can say y is equal to, let's look at this one here. we can say x to the power of 3 over 2. Remember, we're getting rid of the square root. And then we have two brackets. We have x to the power of negative 2 plus x. And then the second bracket, we have x to the power of negative 2 plus x. Let's not forget that there are two brackets multiplying each other there. So we continue on the next step. We're going to write this x to the power of 3 over 2 as it is. And then we do the FOIL on the next one. We're going to say x to the power of negative 2 multiplied by x to the power of negative 2. We're going to have x to the power of negative 4. And then you continue, you say x to the power of negative 2 multiplied by x. You're going to have x to the power of negative 1. Remember guys, the bases are the same. So when the bases are the same, multiplying each other, the exponent will add. We can say x to the power of 1 multiplied by x to the power of negative 2. We're still going to have plus x to the power of negative 1. And then we do the outer part where we can say x to the power of 1 multiplied by x to the power of 1. That is going to give us x squared. Right, so from here guys, we find the like terms. As you can see inside the bracket, we have 2x's to the power of negative 1. So this one here is going to be x to the power of 3 over 2. Then we continue with x to the power of negative 4. And then we're going to have 2x's to the power of negative 1 plus x to the power of 2. So from here now, we can multiply this x with everything inside the bracket. So let's continue. We can say y is equal to x to the power of negative 4. Remember, when the bases are the same, the exponents, they do what? They add. We're going to have 3 over 2 plus we have 2, and then we have x to the power of negative 1 plus 3 over 2. And then we say plus, and then we have x to the power of 2 plus 3 over 2. Alright, so we simplify this. This one here is going to give us x to the power of negative 5 over 2. Plus, this one here is going to give us 2x to the power of 1 over 2. And then the last one here is going to give us x to the power of 7 over 2. So basically, this is what you're going to have here. Now it's time for us to find the derivative, or we derive now. Now that this is simplified, let's derive. So let's start with the first term. But before we derive though, this type of derivative, guys, is the power rule or the standard derivative. So you really don't have to worry that much about it. So already I've left the video in the description. Go and click on that video where I explain the standard derivative. Right, so let's continue. So we know that this is going to be multiplied by the exponent, divided by 2, and then we're going to have x to the power of negative 5 over 2 minus 1. That's the first term. The second term, we're going to have 2, and then we say x to the power of half minus 1. But let us not forget that our exponent is half. Right, then we continue to the third term where we can say 7 over 2, and then we have x to the power of 7 over 2 minus 1. So when we continue and simplify this one here, this is going to give us negative 5 x to the power of negative 7 over 2 divided by 2. And then we continue with the third term. As you can see, this 2 and that 2, they will divide each other. So meaning you're going to be left with only x to the power of negative 1 over 2. And then the last term here, you're going to have 7, and then x to the power of 5 over 2 divided by 2. So to make this one simpler, let's leave our exponent in a positive sign. So we have negative 5 over 2, and then we can say x to the power of 7 over 2 plus we can say 1 over x to the power of half plus this one is fine, it's going to be 7 x to the power of 5 over 2 over 2. Guys, this is how you do this one. I know this was a bit challenging. If you didn't know what to do here, you could have made lots and lots of mistakes. I hope you did not though. So guys, I hope this question you managed to get it. if it so happens that you got confused somewhere, do not forget to rewatch at the point where you got confused, and also do not forget to leave a comment so that I'm able to help you and answer you to my level best. But if this question helps you to understand better, do not forget to like the video and also share the videos to your friends. If you haven't subscribed, subscribe to the channel. Alright guys, we are done with 4.4. we are about to do 4.5. Alright guys, now we have to do the last question of question 4, which is 4.5. So again, this question is claimed to be difficult because they put this. So let's see if really it is that difficult. So let me copy this question and paste it where there's space. Alright guys, here is our 4.5. So they want us to differentiate this expression that you see here, where y is equaling to natural log squared x multiplied by e to the power of x. But then they want us to use the product rule. Guys, when you differentiate this problem here, you need to rewrite this expression here. So let's simplify it and rewrite it in a way that we can be able to use the product rule. So we can say y is equaling to our natural log, it is squared, so you can write it like this: natural log x squared multiplied by ex. There we go. So when it's like this, it's easy for us to use the product rule. So first of all, you need to name these functions here, because we have two functions that are multiplying each other, hence the product rule. So we can say this one here, where we have natural log squared, let's call it f of x, and then this one here, when we have e to the power of x, let's call it g of x. Right, so we need to differentiate both of them. So just in case you didn't know, the product rule, when you differentiate, this is how you do it. You must have the differential of f of x multiplied by g of x plus f of x multiplied by the differential of g of x. So basically, this is the formula that you must use. So meaning we need to differentiate f of x and g of x. So I'm gonna start with f of x. So our f of x is equaling to natural log squared. Then we need to use the chain rule here in order for us to differentiate f of x. So we can say u is equaling to natural log x, and then we can say y is equaling to u squared, because when you look at this here, we have two functions, guys. It's a function within a function, so hence we need to use the chain rule here. So we need to differentiate u. When you say du over dx, this is gonna give us 1 over x, and then when you differentiate this one here, dy over du is gonna give us, by the way, this is the power rule, so it's gonna give us 2, and then we have u. Alright, so let us not forget that we have 2, but what is u? U is actually natural log x. So basically, this is how you differentiate this one here. So we need to differentiate f of x. So f of x prime is actually the chain rule. So we know that we need to say du over dx multiplied by dy over du. So what is du over dx? Remember guys, this is it. So we're gonna say 1 over x, right, multiplied by dy over du. So dy over du is this one here. So we can say multiply by 2 natural log x. So basically our differentiation for f of x prime is gonna be 2 natural log x divided by x. Now we are done with this one. It's time for us now to differentiate g of x. So g of x, we know that is equaling to e to the power of x. Guys, this is an exponential derivative. When we have e as a base, basically our g of x prime is the same, so it doesn't change. Just in case you want to know about this, you can go to the description and there is a video about exponential differentiation. and also there will be an icon that will pop up to explain this differentiation here. Alright guys, so it's time for us to apply this product rule here. So we have the first one here, we have the prime f of x, which is gonna be 2 natural log x divided by x. Remember, this is the one here guys, as you can see, the derivative of f of x multiplied by g of x. So g of x, which is this one here, is e to the power of x plus f of x. So our f of x, we did get it here. Here's our f of x. So you can say f of x is natural log squared multiplied by the derivative of g of x. So here's our g of x, the derivative, which is the same as e to the power of x. So basically this is our final answer. Alright guys, this was question 4.5. It was a bit tricky. You needed to know how to differentiate using the product rule. If you didn't know, then this was gonna be very tricky on you. And at the same time, you are supposed to differentiate f of x using the chain rule. Already done a video on chain rule on this question paper here, which is 4.4. Just in case guys you didn't manage to get this question, you can go to the point where you got lost and rewatch the video again. If it so happen that you don't understand again, you can leave a comment and ask the question. I'll try to answer you to my level best. But if this video here helped you to understand this question, don't forget to like the video, share the video, and also if you haven't subscribed, subscribe to the channel. Guys, this is the end of question 4. So I hope this video helped you to understand. So we are done with question 4. The next video is going to be on question 5. At the end of this video, there will be the playlist of this question that contains all the questions. So click on that playlist to watch all the questions if you haven't. Thank you very much guys for watching. Till next time, cheers.